I'm a straight-A student that has math in my blood and has put countless hours, hundreds actually, into using quadratics outside of school. Here's everything you need to know about quadratics. If you already know the basics of factoring and just want to learn about how to use it for quadratics, skip here. Otherwise, the factors of a number are what the number is divisible by. Here we have 18. It's divisible by 1, 2, 3, 6, 9, and 18. So these numbers are also its factors. We can factor 18 as 1 times 18, 2 times 9, and 3 times 6, where the parentheses shows multiplication. Basically, when you factor a number, you write that number as its factors multiplied together. 18 is like an ice cream cake. And to factor 18 is to see all the ways you can combine things into an ice cream cake. You can have cake with the cream, the ice cream cake base with the toppings, or just the complete cake and the fridge to keep it cool. We can do the exact same things with variables. We can multiply 3x and 5x to get 15x squared. Remember, math is like ice cream. If you go to a restaurant and order scrambled eggs, you can't make the restaurant uncook them. But if our delicious ice cream melts, we can always freeze it again. Likewise, if your ice cream has frozen into a solid ice block that can't be scooped, you can always chuck it into the microwave and nuke it. We can microwave 15x squared by factoring. We know 3x is one factor of 15x squared. And pretending we didn't just use the other, if we divide 15x squared by 3x, we find another factor, 5x. To factor things with more than one term, we have to find which factors the terms share. 5x and 15 both share the factor 5. The factor, we divide both by 5 and then put it outside of the parentheses. If we were to remultiply this out, we just multiply 5 with both terms x and 3, and end up with 5x plus 15 again. Now we can factor quadratics. Quadratics are any expression that have an x squared term. You may also have seen the form ax squared plus bx plus c. To factor a quadratic, we want to get it into the form x plus p times x plus q, where p and q are random variables representing constants. If we were to multiply this expression out by multiplying x with both terms in the second parentheses and then p with both terms in the second parentheses, we get x squared plus qx plus px plus pq. To factor, we need to find two numbers currently represented by pq that add up to the number in front of x and multiply to the constant. This will make more sense with real numbers. Using the equation x squared plus 11x plus 24, we need to find two numbers that add up to the number in front of x, 11, and multiply to the constant 24. To do this, let's look through some pairs of numbers that multiply to 24. 1 and 24 are obviously too big, 6 and 4 are almost right, but 8 and 3 work perfectly. Now we write the factored quadratic as x plus 8 times x plus 3. You might ask, why would we want to change our quadratic from standard form to our now factored form? Well, factored form gives us additional options when approaching problems, as well as allowing us to easily solve quadratic equations. Both standard form and factored form have their uses. Think about ice cream shops. You have your standard ice cream shops where you make all your flavors at the start of the day and let your customers point and choose what flavor they want. These shops are efficient and take few workers to run. There are also ice cream shops with menus. These break down the different types of ice creams into their separate common ingredients and have employees combine them into whatever flavor of ice cream the customer orders. This form of ice cream shop allows a larger menu. To get more effective at math, you should know how to switch between the different quadratic forms. Just like how, to get better at owning an ice cream shop, you should be able to transform your shop at will. When approaching quadratics, pay attention to if any terms are negative. If the x squared term is negative, divide the whole quadratic by -1 and work from there. If the constant term is negative, then we know one factor is negative and one isn't, since you only get a negative when you multiply a positive by a negative. The middle term is then the difference between the two numbers you're looking to find. Here we look for numbers that multiply to 6 and have a difference of 5. These are 6 and 1. Since the middle term is negative, we know that the larger number 6 is negative. If 5 was positive, we would know that 1 is negative. If just the x term is negative and the constant is positive, we know that both numbers are negative, since a negative times a negative is a positive. Some quadratics can be factored into two identical factors. For example, x squared plus 6x plus 9 equals x plus 3 times x plus 3, which can be written as x plus 3 squared. You can recognize perfect square quadratics, which are what we described just now, if the number in front of x is double the square root of the constant. Here, 6 is double the square root of 9, which is 3. We can see this if we multiply out x plus a squared, where a can represent any constant. We get x squared plus 2ax plus a squared, where the constant is half of x's coefficient squared. Whenever you see a quadratic, you should first look for common factors you can factor out. For example, in 2x squared plus 8x plus 8, you should first factor out the 2 and go from there. If you went to an ice cream shop, you wouldn't say, can I get strawberry ice cream, but with double the strawberries, double the ice, double the cream, and like just double everything? It'd be easier just to ask for 2 scoops of strawberry ice cream, just like it's easier to factor out the 2 in the previous quadratic expression. The reason we've learned how to factor quadratics is that we can use it to actually solve for x in quadratic equations. With an equation like x squared plus 7x plus 12 equals 0, we can't just isolate x and find it because we have an x squared term. So instead, we should approach it by factoring. We get x plus 3 times x plus 4 equals 0 after factoring it, and now something magical happens. The special thing about 0 is that when you multiply numbers together, if one of them is 0, the entire expression is 0. If you have 0 cream or milk, even if you have all the ice and sugar in the world, you still have 0 ice cream, just cone of ice. Bleh. 0 times 1 is 0, just like 0 times a billion is 0. So here we just need to find x plus 3 equals 0 or x plus 4 equals 0. Solving both of these equations, we get x equals -3 or x equals -4. And if you plug either of them in, you'll see they both work in the original equation. But what if the other side doesn't conveniently equal 0, like in x squared plus 7x plus 12 equals 2? We then just have to simply rearrange the equation by subtracting 2 from both sides so that it does equal 0. And with the factored form, you'll have to remultiply them out and then subtract from the other side. We then get x squared plus 7x plus 10 equals 0, which factors to x plus 5 times x plus 2 equals 0. Letting both these expressions equal 0, we get x equals -5 and x equals -2. So far, we've only had equations where the coefficient of x squared is 1. When it isn't 1, like 2 or 5 or -13, there are a few things you can do. First, if you're able to easily factor out the coefficient of x squared, then do that and then solve it as normal. Otherwise, you have two options: learn how to factor these types of equations or just use the quadratic formula. We'll start with the formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac over 2a. It seems complicated, but it's pretty simple to use. In this formula, a is the number in front of x squared, b is the number in front of x, and c is the constant. You simply have to just replace the variables with their respective numbers. The quadratic formula is a formula that turns ice cream into ice cream sandwiches. No matter what type of ice cream you have, you can slap it between two chocolatey cookie wafers and it will taste good. Even if you have the crappiest ice cream, or even if there's literal crap in your ice cream, you could probably turn it into an ice cream sandwich and have it taste good. Whenever you get stuck on a quadratic, or you just have really crappy numbers to work with, plug it into this formula. The easiest method to factor quadratics when a is not 1 is grouping. Using 3x squared minus 11x minus 4 to demonstrate grouping, we first multiply a and c, which is -12. Now, like before, we look for numbers that multiply to -12 and add to -11. We get -12 and 1. Now, unlike before, we can't just use these in our factors. Rewrite the middle term as -12x plus 1x, which is the same as -11x. We can now factor these two parts independently. We pull 3x from these two and 1 from these two, which I just pulled out to help visualize the problem. And you'll notice that both of these share an x minus 4, so we can factor that out and rewrite this as x minus 4 times 3x plus 1 equals 0. Now solving both, we get x equals 4 and x equals -1/3. To recap grouping, find two numbers that add to b and multiply to a times c. Then split the middle term into the sum of those numbers and factor the first two and last two terms separately, so they share a common factor. Then finally rewrite it to factored form like before. Now on to completing the square. Before I said that you always want to make the right side of the equal sign 0 before factoring, but perfect square equations are an exception. Consider x squared plus 4x plus 4 equals 9. The left side is the same as x plus 2 squared, since it factors as x plus 2 times x plus 2. Now we just have one x value, so we can simply take the square root of both sides, which gives x plus 2 equals plus or minus the square root of 9, which equals plus or minus 3. because if you take the square root of the number, you have to consider both its positive and negative, since 3 and negative 3 squared equals 9. So we have x plus 2 equals 3 and x plus 2 equals negative 3, resulting in x equals 1 and x equals negative 5. Perfect square quadratics are useful but might feel very situational. Luckily, there's a simple way to make any quadratic into a perfect square, using a method called completing the square. If we have this equation, instead of moving the 9 over and factoring, we could turn the left side into a perfect square equation. Remember, in perfect squares, the constant is half of the x's coefficient squared. So half of 4, 2 squared is still 4, which we already know from before. Now we just need to turn the constant into 4. We can simply add 7 to both sides, giving x squared plus 4x plus 4 equals 16, and we can solve it like before. X plus 2 equals plus or minus 4, so x equals negative 6 and 2. Real quick, if a teacher wants you to complete the square on an expression without an equal sign, you can simply add and subtract the constant that will complete the square. So if we had x squared plus 4x minus 3, we can simply add and subtract 4, which is the same as adding 0, giving x squared plus 4x plus 4 minus 3, which we can then factor and write as x plus 2 squared minus 7. These are parabolas, which are the graph form of a quadratic function, which is the same as the quadratic equation, but we slapped a y on the other side of the equal sign. You'll notice it's symmetrical on both sides, doesn't go past a certain point, and opens either up or down. This is the graph of y equals x squared, which is like the base form of a parabola. It goes up on both sides because if you think about it, any positive number you plug in for x will return the same y value as its negative version. The minimum or maximum point that the graph doesn't go past is called a vertex. To graph a parabola, you really just need a vertex and the 2 points where x equals 0. You can fill in the rest by yourself, making the two sides steeper as they go higher. The vertex form is the form of the quadratic which you can actually use to graph the parabola. It's represented as a times x minus h squared plus k, where a, h, and k are constants. hk represents the coordinates of the vertex. And if a is positive, the quadratic will point up, and if it's negative, the quadratic will point down. In negative x minus 3 squared plus 5, the coordinates of the vertex are 3, 5, and the parabola will point downwards. This might be confusing, but it'll be slightly less when I show you how to get vertex form using completing the square. Let's look at x squared plus 8x plus 23. If we want to find vertex form, we simply complete the square. As before, we square half of x's coefficient and get 16, and then subtract and add 16. The left bit simplifies to x plus half of x's coefficient squared, so x plus 4 squared, and adding negative 16 and 23 we get plus 5. We now have vertex form and can find the vertex, which is negative 4, 5. You might wonder why it's negative 4 and not 4. The vertex is the minimum or maximum point of the parabola, so in this case, minimum. Since this part is always positive or 0, since something squared can't be negative, the y value is minimized when this equals 0, or when x equals negative 4, not positive 4. And obviously, this number will then be the y of the vertex. So that's about everything you need to know about quadratics to get through school, so give yourself a pat on the back. Obviously, I went really fast, so feel free to comment any questions you might have. I'll leave extra practice problems for the different stuff we discussed next to the timestamps in the description. I hope you learned some math and a thing or two about ice cream. Bye.